Hello, Pre-Algebra students. Welcome to Chapter 9.1, which is all about square roots. You probably remember learning about squares in 6th grade math. Now we're going to be talking about square roots. The square root of n is a number m such that m squared would be equal to n. Every positive number has two possible square roots. One square root is positive, the other is negative. A radical sign, which looks like this, represents a non-negative square root. This symbol, which reads plus or minus, refers to both square roots of a positive number. For example, the square root of 100 can be drawn in three separate ways. So first we could put the square root of 100 under the radical sign, and that would be equal to 10, because 10 times 10 equals 100. So this is the positive square root of 100. We could also write the negative square root of 100. That would be equal to negative 10, because 10 times 10 is 100, and we put a negative sign in front of that, therefore it's negative 10. Plus or minus the square root of 100 would be the positive or negative square root of 100, so you would also write that with the positive or negative symbol in front of it. Okay, let's find a square root. In September of every even-numbered year, people in Italy play an unusual chess game. You might notice from the picture that this is a life-size chessboard. Each chess piece is being portrayed by a person. So the chessboard is a square with an area of 324 square meters. So what is the length of each side of the chessboard? Since we know that area is calculated by taking length times width, and that the length and the width of the chessboard must be equal because it's a square, finding the square root of 324 will tell us the length of each side of the chessboard. So we would write the problem in this way. What is the square root of 324? The answer is 18, because 18 times 18 equals 324. You might note that it doesn't make any sense here to find the negative square root of 324, because we're finding a length, and length cannot be negative. Okay, time for a checkpoint. For each of these four problems, find the square root of the number. Press pause while you work, and resume as soon as you're ready to start the lesson again. So far, all the squares we've been talking about have been perfect squares. Again, you may recall this from our 6th grade math work, but a perfect square is a number that's the square of an integer. So for example, 1 equals 1 squared. 4 is also a perfect square, which is 2 squared. 9 is 3 squared, and so on and so forth. However, not all numbers are perfect squares. However, the perfect square is really helpful to us because we can use it to approximate a square root of a number that is not a perfect square. Let me show you how that's done. Let's see if we can find, as close as we can, the square of 51 using perfect squares. So we're going to approximate the square root of 51. So a perfect square close to but less than 51 would be 49, right? Which is equal to 7 squared. The perfect square closest to but greater than 51 would be 64, or 8 squared. We can express this information by writing what's called a compound inequality. We'll start with 49 is less than 51, which is less than 64. Makes sense that it's a compound inequality because we have more than one inequality sign here. The next step will be to find the square roots. So we're just going to go ahead and add that radical sign here. And now we'll go ahead and evaluate. So the square root of 49 is 7. We don't quite know the square root of 51, so we're going to leave that inside its radical. And the square root of 64 is 8. Now our next step is to find the average between 7 and 8. So the average of 7 and 8 is 7.5, correct? 7 plus 8 is 15, divided by 2 is 7.5. So now we're going to square 7.5. You can use your calculator to do this. So 7.5 squared is 56.25. Now we want to compare the square of our average, which is 56.25, to our original number. So 51 is less than 56.25. So from that piece of information, we can logically deduce that the square root of 51 must be closer to 7 than it is to 8. If our number were greater than 56.25, its square would be closer to 8. But since 51 is less than 56.25, our answer is closer to 7. So our approximated square root, we'll write it like this, square root of 51 is approximately equal to 7. Remember, these wavy equal signs mean approximately equal to. So here's your final answer to our problem. The square root of 51 is approximately equal to 7. And here's your checkpoint problem. Approximate the square root of 125 to the nearest whole number. All right, now this really gets fun. Let's talk about evaluating a radical expression. So a radical expression would look something like this. 2 times the square root of a plus b squared. See, I told you this is fun. In this case, a equals 11 and b equals 5. You're going to solve this just like you would solve any algebraic expression by substituting in the values of a and b. So we would rewrite this as 2 times the square root of 11 plus 5 squared. Okay? So that gives us 2 times 11 plus 25. Let's move to a clean page here. So again, here's our 2 times 11 plus 25, 2 times the square root of 11 plus 25, which gives us 2 times the square root of 36, which is 2 times 6, giving us a final answer of 12. See, I told you that was fun. And here's your checkpoint. For problems 6, 7, and 8, when a equals 12 and b equals 4, evaluate these radical expressions. Press pause while you work. There is one last idea in this chapter to return to when you are done with these checkpoint problems. All right, folks, we've made it to our last idea in this section, and that is to solve an equation using square roots. So let's imagine we have an amusement park ride that includes a free fall drop of 272 feet. I don't know about you, but I love these kinds of rides. So you can use the equation d equals 16t squared to determine the time in t seconds that it takes the dropped objects to fall the distance of d feet. So d is the number of feet we fall, and it can be found by taking 16 times t squared. So how long does this free fall take? Okay, well, we know d equals 16 times t squared. We know that d is equal to 272 feet. We can divide each side by 16 to get t by itself, and that would give us 17 equals t squared. If we want to find t on its own, we take the square root of 17 equals t. We are going to put plus or minus next to this. Then we can use a calculator to approximate the square root. So on your calculator, you're going to see a little button that's labeled second. You're going to press that second button, and then you will press the button that has the radical symbol on it. Then you will enter 17, and the answer that will be produced will be plus or minus 4.1 when we approximate that square root. So the final answer for this problem is plus or minus 4.1 is approximately equal to t. We can't say equal to because we know it isn't perfectly equal to. 17 is not a perfect square. So we have to put approximately equal. Now we do have plus or minus, but does it make any sense for the time of a ride to be negative? No, not at all. So our final answer will be that the free fall takes about 4.1 seconds. Probably feels longer when you're on it, but 4.1 seconds is the mathematical answer. All right, thanks for your hard work. I'll see you tomorrow where we will do some practice problems on square roots.